right, so today we're going to start moving into solving quadratic equations, solving quadratic functions. There are 4 different methods for doing this, and we'll talk about all 4, whether it's factoring or the quadratic formula or the square root method. But today we're going to talk about the graphing method. We were just coming off of a unit where we talked about graphing quadratic functions, so it just seems like a pretty easy transition into solving by graphing. So by the time we're done today, you should be able to solve quadratic equations by graphing it on a coordinate plane. Now, to talk about solving quadratic functions or quadratic equations, what we're basically talking about is finding the value of x that makes y equal to 0, right? So here's what we mean. So we know that there are 2 forms of a quadratic function, right? Quadratic function. Ax squared plus bx plus c is your standard form, and y equals a times x minus h squared plus k is your vertex form. What we're trying to figure out is what can we plug in for x to make the y's 0. So what you're going to see a lot of in this particular section is these equations equal to 0. That's what we want to kind of start thinking about. Well, let's think about that. I'm looking for x's that would make y 0. In other words, I want to have points where there's going to be an x coordinate and the y coordinate is going to be 0. If we were to graph a point like that, right? So on the xy axis, if we were to graph a point where the x coordinate is something, whatever, and the y coordinate is 0, where would you find yourself in the coordinate plane, right? Well, if the y coordinate, remember y-axis moves up and down, if the y coordinate is 0, that means we're not going up and down at all, anywhere, right? So what that means is we're going to stay on the x-axis. So maybe here, or here, or here, or here, or here. So basically what we're talking about is we're trying to figure out where these quadratic functions are crossing the x-axis, or x-intercepts. Okay? Now, some other terms that are used for these values are solutions. The x values where the graph crosses the x-axis are known as solutions. They're also known as zeros, and they're known as zeros because, well, these are x's that make y 0. And they're also called roots. A little less obvious as to why they're called roots. But the roots of any function are the x-intercepts, basically. Okay? All right. So if that's the case, with a quadratic, these parabolas, we have 3 different possibilities when we go looking for solutions. We have seen some parabolas where the vertex is above the x-axis and opens up, or the vertex is below the x-axis and opens down. When that happens, the graph does not cross the x-axis at all. So there are no solutions. Okay? We have seen some parabolas where the vertex is actually on the x-axis. Since the vertex is the minimum or the maximum, it's the lowest or the highest point. If that point is on the x-axis, then no other point will be. No other point on the parabola will be on the x-axis, so that means we're going to have one solution. And then we've seen parabolas where the vertex is below the x-axis and opens up, or is above the x-axis and opens down. And in that situation, we've got 2 solutions. Okay? So, knowing which way the function opens, which way the parabola opens, can help us figure out how many solutions we're looking for, right? All right. So, let's have at it. Here is the graph of the function f of x. Remember that f of x is just a fancy y, equals x squared minus 4. And since we're looking for x-intercepts, we see that the graph crosses the x-axis here and here. And so the 2 solutions for this are going to be 2 and negative 2. If we were to plug 2 in for x, that would make the function equal 0. We can check that pretty quickly. 2 squared minus 4 is 4 minus 4, which is in fact 0. Same if we plugged in negative 2. Okay? So easy enough. Just look and see where the graph crosses the x-axis. Here, well, as you imagine, as you might be thinking, the solutions are going to be 0 and 2. What about here? Hopefully you're thinking that the solutions are 0 and 4. If we plugged in 0 or 4 in for that function, then we would get 0 for y. And so easy enough to find the solutions when we have the graph, and we look at the graph. Okay? What about if we have the function but not the graph? Well, it's still not a whole lot harder, just now we're going to have to actually graph this function. Now, as we said before, it's basically like we're trying to put in a 0 for y. We're trying to find the values of x that make y 0. Well, that means that if we're looking at an equation like this, where it's not equal to 0, then we know it's not in standard form or in vertex form. And we can't graph unless this is in standard form or vertex form. So what that all means is our equation has to be equal to 0 in order for us to solve. So in order to make that happen, we're just going to add 8 to both sides here. Now we can see that the 0 was put in for the y right there. Now we can go graph. Now this is a standard form, so you have to remember that we need to go looking for the axis of symmetry. We do that by doing opposite b over 2a. Opposite b is negative 6, a is 1. So we get negative 6 over 2, which is negative 3. So the axis of symmetry is at negative 3. We find the vertex by plugging in negative 3. If we plug in negative 3, we get negative 3 squared plus 6 minus 3 plus 8. So we get 9 minus 18 plus 8, which gives us negative 1. So the vertex is at negative 3, negative 1. Well, I would stop really quick right now. Now that the vertex, now I know where the vertex is, and make sure I know which way the parabola is supposed to be opening. Well, since a is positive 1, it's going to open up. Vertex below the x-axis and opening up means that we are going to have 2 solutions. So we do need to keep going here and try to find those 2 solutions. All right, so we're going to plug in 2 more values of x. 2 more values of x that are going to be close to the vertex and as small as makes sense. So I'm going to plug in negative 2 and negative 1. So if we do that, we get negative 2 squared plus 6 times negative 2 plus 8, which is 4 minus 12 plus 8, which is 0. And if you're paying attention, you already know what one of the solutions are. So negative 1 squared plus 6 times negative 1 plus 8 gives us 1 minus 6 plus 8, which is 3. So we go negative 2, 0, negative 1, 3. And this becomes your graph. So the solutions are, again, where the graph crosses the x-axis. So that means our solutions are negative 4, negative 2. Okay? All right. And that's what I meant by, if you were paying attention, you already knew what one solution was, right? We're trying to find the x's that make y 0. Well, when we did our table, -2, when we plugged in -2, we got 0 for y. So that was going to be one of our solutions automatically. We just had to carry out the graphing to try to find the other one. All right? All right, try to graph this next one. Stop the video, try to graph it. Remember that it has to be equal to 0. The equation has to be equal to 0 to be in standard form. And go graph it and see if you can find the solutions, and then I'll walk you through that in just when you start the video back up. Okay, all right, so we had to add 25 to both sides. Then we got to go through and do our axis of symmetry and vertex. Opposite b over 2a gives us 10 over 2, which is 5. So axis of symmetry is at x equals 5. That means our vertex is at 5, comma. Let's go plug that in. 5 squared minus 10 times 5 plus 25 equals 0. This is 25 minus 50 plus 25 equals 0. Negative 25 plus 25 equals 0, so 0 equals 0. Well, I'm not really sure what the heck was going on there. This should have been a y. We're trying to find out the y value for when x was 5. I forgot to flip over my mode there. So anyway, y is 0. So the vertex is at 5, comma 0. Again, if you've been paying attention, then you already know what the solution is. Now, look, the vertex is on the x-axis, and it doesn't matter if it opens up or opens down. That means we're only looking for one solution. That solution is 5. So we already know that our solution is 5. We can continue graphing if we'd like, right? Plug in two values. I'd plug in 4 and 3. And go find out what the values are for y when you plug those in. And so when you plug those in, you should get let's see, 1 and 4, I believe. Mirror imaging those, and there's your graph. But since the vertex is on the x-axis, there's only one solution, and that's when x is 5. Okay? All right. Now, that's when we're in standard form. We can always take a look at vertex form. And graph this way. Remember that with vertex form, we're thinking about the parent function, whose vertex is at 0, 0, and based on the parent function, we know that the points, there are points on the parent function that are 1, 1, 2, 4, and 3, 9. So basically, or in other words, our 1, 2, 3, 1, 4, 9 table that we're going to use. So we're going to shift and change how the parent function looks. Well, from this, we hopefully remember that we're shifting the parent function left 3, down 1. That means our new vertex, left 3, down 1, is at -3, -1. Right there. This is going to open up because A is positive. And so, how does the rest of the graph look? Well, we know that we're going to change the way we walk to each point, and we're going to use the parent function table to help us figure that out. Now, A is 1, so we're going to multiply everything by the guy in the right-hand column by 1, and we get the same values, 1, 4, 9. So That means if we walk over 1, we go up 1. If we walk over 2, we go up 4. And I'm just mirror imaging for the second point that I'm plotting here. If we go over 3, we have to go up 9. And we're done. And we graph. Okay? And so we see the solutions are, I think this might be the exact same function as what we just found the solutions for, but the solutions are -2 and -4. Okay? All right, and that's it. So, this may be different than what's on your notes, but let's go ahead and graph. Let's make this a 4. I think that is the same as in your notes, but leave A as 2. We need to remind ourselves how to graph when A is something other than 1. So let's make this your function. Let's go graph that guy. Stop the video, start it back up, and see where your solutions are. Okay, again, we're shifting the parent function. And so we're shifting the parent function left 1, down 4. So our new vertex is -1, -4. And then we got to change how we walk from one point to the next. So our 1, 2, 3, 1, 4, 9 table, multiply it by A, multiply the right-hand column by A. So instead of 1, 4, 9, we get 2, 8, 18. It means when we walk over 1, we got to go up 2. When we walk over 2, we got to go up 8. 2, 3, 4, 5, 6, 7, 8. Mirror image these points. And there's our graph. Now, we're looking for where the graph crosses the x-axis. So where are our solutions? Well, here is the issue with the graphing method, right? It's the same issue when using the graphing method for anything else. That's not always the most accurate. We did not have points as we were graphing this guy land on the x-axis. So it becomes really tough to tell exactly where the solutions are. We think it might be -2.5 and 0.5, but we're not real sure. That all depends on how well you are at graphing these parabolas. So that's why we do have other methods, and we'll talk about all of the other methods in the coming days. That's also why we have graphing calculators. We can much more accurately find these solutions by using a graphing calculator. And so that's what we want to do now. Let's go use a graphing calculator and help us figure out how to find the solution a little bit more accurately. Okay? All right. Well, these are for you TI people. Casio people, you know that we're looking for roots. So you have to make that transition. But we're going to go graph this line. So we got to type it in. So we go 2 times x plus 1, I believe it was. Let's go look. Yeah, plus 1 and then minus 4. Plus 1 squared minus 4. We hit enter. We go graph. And so there's your graph. Now what you may need to do is try a different zoom. You could do zoom fit. I don't know if it's going to make the graph look any better for you. Or you can hit zoom and try zoom standard. Zoom standard makes the x and y axis go from -10 to +10 and scale each tick mark by 1. And so it should get you looking at the graph like this. all right? Or just go into your window and type in negative 10, 10 for your x minimum and maximum, negative 10 and 10 for your y minimum and maximum. Make sure that your graph is scaled by ones. All right, now remember that these are called zeros, so we need to second calculate and go looking for a zero. Now, you TI people, we've done this before when we started trying to figure out when balls land on the ground after being launched into the air, things like that. Remember that the TI, the Texas Instrument calculator, wants you to set walls around your zeros, and it wants you to set the left wall first, so we got to keep arrowing to the left until our cursor goes past the first point that we think is a zero. Hit enter, and then we're going to arrow to the right till we're just past where we think the graph hits the x-axis, and then we hit enter. So we're going to set our left wall, then our right wall, and then we hit enter again to have it calculate the solution. And it looks like that we weren't too far off, but it's not negative 2.5 as the solution, but it's negative 2.41. Okay? And then, of course, we do the same thing to go find the other zero. So just to the left of the next zero, and then just to the right, then hit enter. And again, we see we weren't too far off, 0.41. Okay? And again, Casio's, once you have yours graphed, you're just going to hit second solve and go find the roots. And it'll calculate it a little bit more easily than what the TIs do. Okay? So that's a quick reminder on how to do that. Why don't you go ahead, and there are 3 more problems in your notes. Go ahead and find the solutions with your graphing calculator for those 3 functions. Okay? You can stop the video and then start it back up, and I'll find the solutions as well, and hopefully we'll get to the same things. Okay?
Should I show you this morning?
All right. Let's see what you got for what you should have gotten for your solutions. So, clear this out, type in the first equation. Now remember that you had to move everything over to make sure the equation was equal to 0. So 2x squared plus 4x, and then instead of plus 6, it should have been a minus 6. You had to subtract 6 from both sides, right? Then go graph that. We hit second calculate. We're going to calculate a 0. We're going to left arrow to just to the left, well, just to the left of the where we think the first solution is, and then hit enter. And so it should have been negative 3. Negative 3 would have been the first solution on this first problem. And then we do it again. So I'm going to set the left wall right there, the right wall right there, hit enter, and the solution is at 1. So negative 3 and 1 were solutions for that first guy. All right. Now let's type in the second equation. Let's see, the second equation should have been 5x squared by the time you're done getting this equal to 0, plus 6x minus 1. And graph that guy. And we want to calculate a 0. Left wall there. Right wall there. Hit enter. And you see that the first solution is negative 1.35. It did ask us to round to the nearest hundredth. Then find the next 0, arrow just to the left of the first solution, and then just to the right, hit enter, and 0.15. Okay? And last but not least, type in The next function, which was 10.09, this would have been a nightmare to graph. And then plus 4.56 x. By the time you're done getting that equal to 0, hit enter. Graph. That's a little bit tougher to see, so I'm just going to zoom in. And we'll zoom in right there. That's better. All right, a little bit easier to see. So let's go second, calculate a 0. Arrow just to the left of the first, what we think is a 0, and then just to the right. Hit enter. And the solution is negative 0.45. And hit second, calculate. We're going to calculate a 0 just to the left of the next guy, just to the right, and then hit enter, and the next 0 is at 0. Okay? And that's how you use your graphing calculator. Feel free to use that to check your answers as well. Okay? But that's all there is to it. Homework's out in Canvas. Make sure you have that done by next time.